To round out our terminology today, let's introduce two more terms. The first one is latency, and that's mostly what we've been talking about. That is how long you have to wait for one small thing, say, to go from one point to another point. And this is a time, such as milliseconds, right? And round trip times are our normal measurement to talk about latency. There's another measurement that's relevant and not quite the same thing, and that is throughput. So that is how long you have to wait for everything, not just for one small piece to get there. And this is going to be a rate such as bytes per second. So sometimes for some applications, you're most concerned about latency. You have a small message, and what matters is how long it takes for that one message to get there and back. Like if you're doing a distributed video game, then the responses of different players is the important thing, and the latency needs to be low there. Often, and maybe more often, you're interested in the throughput. How long do you have to wait, not for one piece of the file to get to the other end, but for the whole file to get all the way there? And that has to do with how big your file is, of course, so you express it as a rate. Sometimes you can have very low latency, but also low throughput. Sometimes you have low latency and high throughput, which is the ideal situation. The analogy I always find useful for keeping in mind the difference between these is if you put a bunch of flash drives on a big truck and have the truck drive across the country, that can be very high throughput. A lot of bits get moved from one point to the other. But it's going to be very high latency as well. That is bad. It's going to be slow in terms of one individual piece, one of those little flash drives, getting all the way across the country. So latency and throughput, ideally low latency, high throughput, but you can't always get both of them at the same time.